Hi everyone. We have a circular room with a radius of 11 meters. We need to find the area. I guess we're going to paint the floor and do other things. Well, the most easiest way we all know is the formula for an area. Area is pi r squared, pi times 11 squared, which is 121 pi meter squared, because 11 squared is 121. There you go. And if you want to plug in pi to 2 decimal points times 3.14 to the nearest digit, the area will be 380 meters squared. But I'm going to try it the other way, and that's using calculus. And of course, the question is, why would we need calculus if we can solve it an easy way like this? This is a great way to practice calculus. It's a great way to show that mathematic theories are proven to be true. If we don't make a mistake, we should get the same answer. And it's also explaining a concept. What if we have a shape where there is not an easy formula? We'd have to find another method. So let's get on to the calculus. That's the formula for a circle of radius 11 on an xy plane. X squared plus y squared equals 11 squared, which is 121. I'm going to just work in this quarter here, where x and y are both positive, and when we're finished, we'll multiply by 4. That will make it easier. So I'm going to do now is isolate the y. Bring the x squared to the other side. We get y equals the root of 121 minus x squared. I rooted both sides. That's the formula with y as the subject. I want to find the integral of this formula from x equals 0 until x equals 11. And that would be the area for that quarter. It's 0 to 11 of the root of 121 minus x squared dx. I'm now going to do trig substitution because I'm going to reach a format which I have formulas to solve. I'm going to let x equal 11 sin theta. See, that's 11 squared, that's 121. Dx equals 11 cos theta d theta. I took the derivative. Derivative of sin is cos. And now we substitute in. Firstly, when x is 0, theta will be 0. Because sin of 0 is 0. So when x is 0, theta is 0. And when x is 11, 11 equals sin theta, 11 equals 11 sin theta, 1 equals sin theta, where sin theta is 1 when opposite and hypotenuse on top of each other. See that hypotenuse swinged up there? That's when opposite over hypotenuse is 1. That's when theta is pi over 2. When x is 1, theta is pi over 2. So now we're going to substitute in for x and replace it from our new formula. So instead of saying 121 minus x squared, we just said x is 11 sin theta. So it's 11 sin theta squared. That's I replaced there. And instead of dx, we're going to put 11 cos theta d theta. And we're now going from 0 to pi over 2, because when x is 0, theta is 0, and when x is 11, theta is pi over 2. So that's our new integral, and I'm just going to simplify now. Instead of saying 11 sin theta all squared, I'm going to write 11 squared sin squared theta. And next of all, the only change I made from the previous line, that 11 squared was replaced with 121. Now, also I'm just making one change. I'm taking that 121 out as a common factor, and we're left with 1 minus sin squared theta. And remember our famous formula, sin squared plus cos squared equals 1. If we bring that sin squared to the other side, there's 1 minus sin squared theta. We can replace that with cos squared theta. So instead of 121 times 1 minus sin squared theta, it's 121 times cos squared theta. And of course, when I'm making a change to one part of an equation, everything else stays the same. I just rewrote everything else. And that's the whole purpose of substituting in at the beginning, when I said let x equals 11 sin theta, it's because I'll be able to take this out as a common factor. And the root of 121 cos squared theta is a root of 121, which is 11. The cos squared theta is a quick way of saying cos squared times, a quick way of saying cos squared theta. Another way of saying that is cos theta times cos theta. So the root of cos squared theta is cos theta. And as my chains are here, everything here is staying the same. And now we simplify some more. 11 times 11 is 121, which I can write outside. And cos theta times cos theta, because this cos squared just became cos, is simply cos squared theta. And this is what we have at the moment, the integral from 0 to pi over 2 of 121 times cos squared theta. Now to have some more fun. Remember the equations for cos of 2 theta? There's a few of them. It equals cos squared theta minus sin squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sin squared theta. If I take this equation, that cos of 2 theta equals 2 cos squared theta minus 1, I isolate that cos squared theta. I land up with cos squared theta equals 1 plus cos 2 theta divided by 2. And that's what I have over here. And it's not serious. I forgot to write the d theta here. Depending who your instructor is, they may or may not be happy. And now I'm just going to simplify. I'm going to bring this, choose a constant, I can bring it out. So I've got 121 divided by 2 of the integral of 1 plus cos 2 theta from 0 until pi over 2. And now there are many correct ways. Some people might multiply this number in, the 121 over 2. Some might separate into two separate integrals as addition sign. Multiply this in, say, the integral of this plus the integral of that. They're all correct methods. So I think the way I'm doing, what I'm going to do now, I'm just going to straightforward do the integral. That's a constant outside. The integral of 1 is theta. And the integral of cos 2 theta is sin 2 theta times a half. Because when we do this derivative going that way, we'll have to multiply by 2 because of the chain rule. That's why I have that half over there to bring that to a 1. And so that's the integral. And it's stretching from, I'm going to make this clear because I wrote too. This is part of this integral. That's the different line from pi over 2 to 0. Or those changes are made. Some can do it after doing the integrals, or one can multiply that in before the integral or after the integral. They're all correct ways. I chose to multiply this 121 over 2 in, 121 to pi. And if I multiply it into the other side, it's 121 over 4 sin of 2 theta from pi over 2 to 0. Now again, some people might prefer to keep this 121 over 2 outside. It doesn't matter. Now from 0 to pi over 2, it's this equation twice, plugging the pi over 2 in and plugging the 0 in, and one minus the other. I wrote it over 2 lines so it'll fit nicely in the camera. In essence, this is between my 2 fingers is 1 line. It's this equation, subtract that equation, and they're both the exact same equation as this one, except one substituting pi over 2 and the one substituting in 0. And I wrote it in pencil so you can see we're putting pi over 2 in there, and I'm putting 0 in there. And you can see both of these 2 equations are exactly identical, except I'm plugging in a different number in for theta. And they are both identical to this equation, except there I had theta, there I'm substituting either pi over 2 or 0 for theta. Now to simplify, 121 times pi over 2 and 121 over 2 times pi over 2 is 121 times pi divided by 4. 121 over 4 stays the same, and 2 times pi over 2 is simply pi. So that's simplifying the top equation. The bottom equation, we substitute 0 in there, is 0 times 2. We've substituted 0 in there. 2 times 0 is 0, so it's 121 over 4 times sin of 0. Okay, so now it's still just simplifying. This 121 over pi over 4, I'll rewrite over there. And what's the sin of pi? The sin of pi is 0. If you visualize that horizontal, that hypotenuse going over, when it reaches pi, which is here, that opposite has collapsed to 0. So this sin pi can be replaced with 0. There it is. So now on the second line, 121 over 2 times 0. That's a difficult question. Times 0. Let me check in my calculator. 121 divided by 2 times 0. Equals 0. Never guess it. Equals 0. And the sin of 0, I'll rewrite there. The sin of 0 is 0. Think of that opposite here. When that angle is 0, that opposite is 0. So we've got 121 pi over 4. I rewrote there. 121 over 4 times sin of pi is 121 over 4 times 0. 0, I rewrote as 0. And I just agreed that 121 over 4 times sin of 0 is 0. There's 121 over 4 times 0. Okay, next up. Now we're simplifying. 121 pi over 4, I rewrote. 121 divided by 4 times 0. Again, let's check in my calculator. Yep, it equals 0. I spent more than 20 years giving private lessons in math, but I need a calculator to multiply by 0. Actually, it's more my sense of humor. I can multiply by 0. And 0 plus 0, that's another tricky one. I happen to believe it's 0 plus 0, which is 0. It cancels out. This 0, this 0, this 0 all cancel out. We're left with 121 over 4. That's the area of that quarter. Now, to find the area of that entire circle, we have to multiply by 4. Remember, we found the area of a quarter. 121 pi divided by 4 times 4 is 121 pi meters squared, which matches what we had up there. That's beautiful. So we got the same answer, both using a formula and calculus, which shows calculus uses methods which are proven to be true. Thank you for watching. I appreciate it and talk to you all soon.